Alrighty guys, we are back with the most intimidating part of learning EKGs, which is going to be the sodium potassium pump. It's not that hard, it just kind of feels a little bit different than what you think you're learning. You think you're learning about the P and the QRST and what the heart's doing at that time, but we also have to learn about it at cellular level, which is what the sodium potassium pump is. So, your heart has three main electrolytes in it, which is going to be sodium, potassium, and calcium. In a resting state, this is kind of our visual, this is your cell, and your cell wall is going to be negative, and then in this external space, this is like more positive. Inside the cell, you're going to have potassium cells, and then on the outside of that cell, you're going to have your sodium and calcium. The important thing to know is that all three of these are positive. However, sodium is more positive than potassium. So you'll hear that a lot with actually the electric stuff with the heart. Some things might not be negative, but they are less positive than the other. So I want you to think of it as when you're wrestling or arm wrestling or whatever, like you can both be strong, but somebody is going to be stronger and win that space. And so that's kind of what we're thinking about with the sodium potassium pump. So we know that the heart cells are specialized and that there is a level of automaticity. So we don't need something to make it go. It just fires on its own. All right, so in our resting state, like we're saying, we have sodium on the outside, potassium on the inside. This is our on your marks get set, okay? This is the polarized state. When depolarization happens and it discharges, sodium, which is stronger than the potassium, the sodium and calcium rushes into the cell and pushes the potassium out because it's bigger and it's stronger, okay? At that point, when it discharges, it pushes all of them out, and that is kind of the pump, okay? And then it repolarizes, which is kind of when these are kind of mixed in a state. There are parts of sodium on the inside and on the outside, and there is also potassium on the inside and the outside. And then it goes back to a polarized state, which is this starting point, okay? So we'll get a little visual. Let's see here. So this is from the paramedic coach, which I really like. Sorry, this projector is slightly annoying. But so just like we have here, this is the resting state. You have your sodium on the outside, potassium on the inside. And then during depolarization, it starts to rush in and push the calcium out. So these two little boats symbolize that, just kind of at different points in time, I suppose. And then repolarization, they're exchanging spaces again, and the sodium returns to the outside and the potassium is back inside of the cell. Okay? So that's your sodium potassium pump. It's really nothing crazy. It's just knowing which cells are more positive than the others and what they're doing at what time. But that is what causes that push down the pushing of the child down the slide, if you will, when it comes to the electrical system. It is just that initial pump, that pushing the kid, the initial impulse. And that's all that there is to